All right, so welcome everybody to the Advanced Assembly Design class, and everybody out there at GVC. We do have a Dory for you if you are watching live stream, so if you want to ask questions, I will stop periodically and ask if what I'm saying is clear. But we're going to jump into it. What we're going to talk about today is a little bit about the assembly design as far as the assembly structure and how SolidWorks operates and what it loads in when you get an assembly. Maybe get some better performance out of your assembly, some better designs. Usually I try and stay out of the options page on one of these because it's not a great, motivator to begin your presentation, but there's some important stuff here in the options. There's one that says assemblies, so I'll start with that. Over here on the right, you'll see these thresholds. These are set up by SolidWorks for different types of assembly loading that you can do onto your machine. These numbers, I don't know why Dassault picked these numbers, or SolidWorks picks these numbers, but they're kind of high in my opinion. If we knock this down to about 250 for large design and maybe 1,000 for large design review, I usually get a little bit better performance from my machine if I'm running in that mode. More often it's going to be loading up stuff sort of virtually rather than actually loading everything into my RAM. There's also this performance page right here, and it talks a lot about loading stuff lightweight or resolving components inside of assemblies. That's what that large design, large assembly, this one, the large assembly mode, puts everything into this lightweight mode. And you'll see what that is. Basically, it just loads up the graphics and the reference material, or sorry, the reference geometry from the part. It doesn't load in all the parametrics, all the metadata, all that other stuff into your computer, so it takes less time to load up. Because when you are loading up an assembly, there are 4 different things that are getting loaded up. Now that I've got these set, let me double check to make sure I've got them set where I want. Nope, I forgot to hit OK to apply them, so let me put them back on. Now that those are applied, when I go to my file open and I look to a folder, down here you'll see these are relatively new. These filters, I can have SolidWorks just show me the assemblies with this button down here in my file open. So that's just showing me assemblies. It's got another button to the far right, which is all my top level assemblies. You can see a preview when you click on here. And basically all a top level assembly is something it isn't rolled up into another assembly. So it's not necessarily the largest assemblies there. It's just from this point, it doesn't get loaded up into anything else. There isn't a where used above it. So those are all the top level. Everything else reports to them. Yes, sir.
Do you need to be in a vault for that to work?
It works in local vaults, local files and vaults. You do need to go through the file open. Okay. If you double click out of a Windows Explorer, it's going to ignore that and just load up everything resolved, which is the slowest way to do things. You'll see that some of these things load up resolved. Some of them load up large design review. You can switch that if you want. But resolved means it's bringing in all the parts into RAM. It's bringing all the parts graphically and resolving them. And that takes the longest to load up an assembly. So if you're in this file open and you get something with this large design review, when you open it, we can give it a count, go 1, 2, tells me, hey, you're using this tool, 3, 4, 5, 6, about 6 seconds, I'm ready to go. So this is the very top level assembly of this design. If I go into the performance evaluation button here, you can see that this assembly has over 1,300 files inside of it. That's counting sub-assemblies, counting parts. The real crucial part is this unique parts, because it actually has to load a file into RAM for each one of those. In this large assembly mode, though, it did not load any of that. This is in the assembly, and I can see it graphically. The graphics here are similar to an e-drawing. If you ever used EPDM, you've got that preview, the 3D preview, that's using an e-drawing as well. There's information stored inside of a SolidWorks file called graphics information. And basically, it's the model, but it's been tessellated. It's been broken down into thousands or millions of little triangles to make the shape. So when you go to measure off of this, the measurements aren't going to be exact. The measurements are going to be to those tessellated facets. They're going to be to those triangles. So the warning is telling you, hey, your measurements in this large design review are not going to be completely accurate unless you resolve the components. Typically when you're at this level, if I just want something like an overall height, so I can see if this thing will fit through the door, I've got this number here, which shows it's almost 2 meters if I have to get through a 3-meter door or something like that. That number is good enough. I don't need an exact, out to the decimal places exact for what I'm taking measurements here for. That's the type of measurements you can take in large design review, just sort of overall ballpark estimates. If you do need it to be, exact on, especially when you're dealing with surfaces that are organic or circular faces that are going to be busted up into those facets, the decimal places after your measurement may not be accurate. So you want to keep that in mind. But it does load a lot of graphic information in here. I can, for example, take a section view on this thing and see what kind of detail is inside of it. Again, I still haven't loaded this thing into my machine yet. I'm really just looking at this top level sort of Super E drawing. If I go to the File Explorer over on the right-hand side of my screen, that wants to take me into a vault. Not going into a vault for this one. It'll show me recent things I've opened up, but there's also this right here, open in SolidWorks. All I have is one single file open in SolidWorks right now. That's why it only took seconds to load it up, because it was like I was opening an E-drawing. I just have some ability to get things like part counts, see sections, take measurements. But when you're looking at this top level of a project, that can get you through at this level. When it comes time to getting more granular, so if I switch this to drawings here, you'll see that when I pick different drawings, look down here at the mode. When I switch to different assemblies, some of them are large assembly mode, some of them are resolved. Again, that's set by that trigger that I said at the very beginning where I said, okay, this is going to be considered a large assembly. This is going to be considered a large design review. I'll open this one in large assembly mode. And 1, 2, 3, 4, 5, 6. Still opened pretty fast. If you look at what's open in SolidWorks, take a look at this tree over here again. Before it just had that one item, Pelican 4, which was the very top with the forklift and the trailer and the works. The other 4 things that are open now opened up when I opened this one file. You'll see that if there's color icon in front of it, that means it actually has a SolidWorks window open. If they're clear like this, that means that they've just been loaded into RAM. They're not actually open in their own window, but they have been loaded onto your machine. So I asked it to do large assembly mode, which is supposed to load everything lightweight. These are lightweight components here. You can see if they got a feather in front of them, that's lightweight. And all that loads up is how it's mated into the assembly and any reference geometry that you've put into the part. So in large assembly mode, I can make copies, I can mate things, I can actually do some assembly work. You'll see that my my command manager is the regular assembly command manager, where if I switch back to this Pelican 4, this is a very abbreviated command manager where I only get to do a few things. Take measurements, look at the hierarchy, but inside this hierarchy, there's no part information at all. It's just a list of the files that it takes to load this thing up. You have a question, sir?
Sure. How do each of these handle whenever a part has been changed or the assembly has been saved since then?
That's a good question. So he asked me, how do these deal with changes? If you make a change to the assembly and then you open it up in either large design review or lightweight, what happens then? That's what your question is? Let's go back in the options. So if I go into assemblies, for the large design review, the only one that really matters is right here. This update model graphics when saving. That generates a new e-drawing 3D image for your assembly every time you save that subcomponent. And so when you roll up to that larger assembly, that should update. In fact, it'll give you a warning that says, hey, the graphics need to be updated. If you don't have this checked on, you have to do it manually and say, yes, update it. If you have this checked on, it'll be every time you hit save, it'll recreate the 3D graphics. When it comes to a lightweight part, you have options here as far as check out-of-date lightweight components or resolve lightweight components. So what I can do here, this is grayed out because I've actually got this assembly open. It's kind of screwing with it. Maybe if I switch windows, it'll be a little more open. No, it's still grayed out. I think it's because I've got assemblies open. It's not going to let me make the changes since I've already opened them. But before these are open, these will be highlighted. And it's this one right here, check lightweight components. Right now it's set not to, so that's the danger you were wondering. What if somebody's making changes and you have it lightweight? You don't know those changes are happening with the default settings. Just because it's you, Charlie, and because I haven't gotten very far, I'll eject out of here and hopefully get there they are. These things not grayed out, just to show you the different choices. So don't check is by default. If you are going to run lightweight, it's probably a good idea maybe to change this. It may slow down because when it goes to load everything up, the other one took me 6 seconds, it's going to have to load anything that has a change into RAM. So if there's a dozen changes, it won't take very long. If there's hundreds of changes, it might take a long time. But if there's hundreds of changes, you would probably want to know about that, right? The other option is I can have it indicate changes. When you open up a lightweight component and a part is out of date and it's basically just checking the timestamp on it, it doesn't really go into what changed on the part. It's just, hey, this has been saved since the last time I saw it. It'll flag, instead of a blue feather in front of the part, there'll be a feather with red stripes on it to let you know that that is an out-of-date lightweight part. And the last one is to always resolve, and that's just if it finds something that's out of date, it loads it up into RAM and resolves it into the assembly for you without asking any questions.
Is there a difference between how large assembly mode and large design review handle this?
No, large design review, it will tell you stuff is out of date when you open it, but it won't automatically solve things like the lightweight would. Okay. So the large assembly mode's a little better for actuality. The large design review is something that you're pretty sure people have saved everything and you're just taking a look at the big picture, the eagle eye type of thing. If you're truly going to be working on it and opening up parts and seeing how they fit together, probably the large assembly mode's better for you. Does that answer your question? All right. Was it a trick question? Did you know the answer when you asked? Okay, good. Let me go back into these things. Again, so I'll open this one large design review. If you don't want to show this again, don't show that again. It'll stop asking you about that. That'll take 2 seconds off of your load time right there. All right, and I opened the other one in large assembly mode. Just getting back to where I was as far as what's open in SolidWorks. So remember, more than one thing opened up when I opened up this radial engine. So this assembly loaded up in the background. Actually, it opened up a couple more last time I did it because I must have had some changes that I did and hadn't saved them. So it loads in whatever it takes. If you have a flexible subassembly, so if we take a look at this subassembly, if I just click on it, open, this assembly has some motion to it. Woo. So obviously I wanted that loaded up at that lower level so I could make sure that everything ran and didn't, run into objects as it was moving. Here at this level, I've got it set to be able to move. So it can move inside of the little cylinder heads if I want to keep looking at that. That's an option right here. This button right here, when you click on it, this makes subassembly flexible. That turns on or off the fact that your subassembly can move. By default, your subassemblies will always come in rigid, where it's like they've been welded together. And that's just a trick for SolidWorks to perform faster. When we're talking about performance at assembly level, there's the hierarchy, how many parts you have in, what type of information you're bringing in. And there's also the mate information is coming through there. So the stuff that needs to load, if I turn off this flexibility, it doesn't have to load all of those mates down at the subassembly level. If it's flexible, it has to load those all up so that it can solve them when I go to move it. If I turn that flexibility off, all of a sudden this thing's not going to move at this level. It'll still move at the subassembly level, but it'll make this assembly solve a little bit faster because it's got that many less mates to have to bring in and calculate for where the position is on everything. All right, and you'll see that when I opened up that subassembly, my open in SolidWorks, tons of stuff opened up. Whenever you do an open like that, like from here, it'll open it resolved, and that's what it did. I closed out that part. If I say refresh, SolidWorks is not always the greatest about purging things out, unfortunately. Sometimes it does when you close the assembly, like if I close this top level assembly, it purged out everything. But because that was a subassembly inside that assembly, when I opened it up, it loaded into RAM. It forgot to get rid of the bags later when I closed it. So you do want to keep an eye on this open in SolidWorks. That's what can slow you down a lot. All right, let's take a look at another assembly. Before I do, this feature manager tree looks a lot like the feature manager tree inside of SolidWorks. I can play around with, what configurations are there or see the hierarchy. You can also search whether you're in the large assembly mode or the large design review or just a regular SolidWorks part. You can always type in numbers here, and you'll see that it'll start filtering out stuff that has that number in it for you. So a quick way to search things also, it pops open your feature manager tree to show me anything with a 73X in it. So the stuff that was, collapsed underneath it before is all showing me anything that's partial to this search that I've got in here. I can open files directly from large design review. When I do that, it does open them up resolved. You can usually tell if something's being loaded resolved. You'll see down at the bottom of your screen it loading up a lot of items. But take a look. This has loaded up fully resolved. It's not in large assembly mode. It's just in regular old SolidWorks fully resolved mode. There's some other layers to what large assembly mode does for you. So obviously, the first thing that you see is the fact that these items have a little blue feather in front of them. Again, like I said, what that means is that the parametrics, the metadata, all the supporting information from inside the SolidWorks file is not there. All it's showing you is the graphics and the reference geometry. If you would like to make changes to a part, so you see that when I highlight this, highlights over here, it's got a blue feather in it. If I double click on it, no longer a blue feather in front of it, it has loaded that part into RAM, which means that I can go in, I can make changes to the parametrics inside there or into the metadata or whatever I want to make a change to. It actually has loaded that file onto my computer and I can make changes to just that one file while the rest of the assembly remains in large assembly mode, or in this mode where it's lightweight. Besides that, it turns off all the graphics that it takes to draw the picture. So you'll notice that this is not in shaded with edges, it's just in shaded. Also, these items are all hidden. I can't show origins if I wanted to. Things like real view are turned off. So it's dumbed down the graphics where it's not drawing sketches, it's not showing planes, it's not showing origins, all this other stuff it would have to draw, especially when we get into like 1,000 parts. If it's drawing 1,000 origins, it takes a while to recreate that as you're spinning. If I go to my view, pull down here, go to hide show, it's turned this on, hide all types. I can override that and turn them back on. And now when I click on this, I have full access to that. So the large design view, it opens everything up lightweight. It also does stuff graphically for you. You can do it yourself manually. I can right click here and say set resolve to lightweight. And you see my open in SolidWorks clears out because it kicked everything out of my RAM. The other thing under tools is this large assembly mode. I can turn that on myself and you'll see that it goes to shaded without edges. It hides all the graphics for me. So those are actually physical toggles you can do manually. So if I wanted this thing to be resolved and in full mode, I could do that. Turn off the large assembly mode, right click here, set lightweight to resolved, and this would be where the real count is, where instead of loading up in 5 or 6 seconds, it might take 30 seconds to load something this size up. You can rotate it while it is loading up, so it does load up part of the graphics in there as you're loading up the files into RAM. So if you take a look at evaluate, you've got this performance evaluation. I showed you this a couple times. It gives you a count on the parts, the unique parts, the sub-assemblies. Some important ones you might want to take a look at is the depth right here, maximum depth of 3. What that means is I have a assembly that has a sub-assembly with a sub-assembly inside of it. If I added another sub-assembly inside of that, you go to 4 levels deep, 5 levels deep, and so on. It's a good idea to not go above 5 levels deep as far as your maximum depth. It gets difficult for the bill of materials functions inside of SolidWorks to get those correct, to get all the parts correct if you go too many levels deep, depending on how you have your bill set. Okay, but that's a little bit about the performance of just opening up a assembly and working with it. So there's things that have to be loaded. You have to load the files themselves as far as the RAM and the feature manager tree hierarchy. The files come with parametric data. The more difficult the surfaces are, the longer it's going to take to draw the pictures, but also if you have a part that is underdefined, all your sketches don't have all the dimensions in them, it takes longer for that to load up. Also, if you have mates that need to look at geometry, like a width mate or something like that, or a limit mate where it's comparing this part's location to this part, that's going to take longer too because it's got to evaluate where they are in space and put them where they go. Whereas something like fixing a part or mating it with just 3 coincidences to the plane or something like that, that's going to not take any time. If it's fully defined, it loads right away. It doesn't have to think about its location. So you've got the parts, the parametrics, the mates, and the last thing is you've also got external references, which we want to stay away from like the plague. And I'll talk about those at the end of this presentation more in detail. One other thing, inside of SolidWorks 15, I believe they put this back in. We go to SolidWorks 2016, go to Tools. There's a tool called Treehouse. And what Treehouse allows you to do is you can drag and drop a SolidWorks assembly into the Treehouse if you have an existing assembly, and it'll show you graphically what the hierarchy of this assembly looks like. So you see it puts together a little tree for me here. If you see multiple stacks, that means that there's more than one. So there's 18 of these, 2 of those, 16 of those. You can reference information like custom properties from here. You can also do some low-level configuration management, though we want to stay away from configurations just as bad as we want to stay away from external references. But there's also a planning component you can do this. If I wanted to create a new subassembly, I can drag and drop a file into there. I can drag new parts into that subassembly, drawings, things like that. You can assign if you want somebody to make a drawing. If there already is a drawing, you'll see one of these flyouts for the part. So it'll show you what you've got existing now, but you can also build one from the ground up, or you can assign like, okay, I need drawings for this, this, and that. It's a good way to take a look at where your project is from a bird's eye view. Yes.
A question. From the help, it looked like you should be able to move a part from one subassembly to another by shift dragging, and I tried that. It doesn't seem to do that. In
this tool?
Yes.
No, I've never done that. So, okay. It's not working for me either. I just tried to shift drag, but yeah, I've never been able to reassign information. You can do it from the SolidWorks file. You know, if you need to think about where things are going to go, like if I want this part, which is here right now, actually down in this subassembly here, I can't do it in the large assembly mode. I'm sorry, the large design review, but I can do it from large assembly mode. And you can actually go into just regular SolidWorks inside this tool as well. If I just right click and set it to resolved, this one's going to take the longest because this is the big part. But no, it looks like large design review or the treehouse isn't really good for rearranging where things are inside of the subassembly space.
So a question.
Sure.
If you have an assembly open, you can individually set components to lightweight.
Yes.
So if you, practically speaking, if you do that for every single part, is that the same as opening it in large assembly mode?
Well, the thing is that that hits you on installation. It's coming into your computer.
Yeah.
So if you bring it into your computer resolved, that's where the problem is. It's while it's loading up. Lightweight's only going to help you out when you're doing that file open and it brings up the assembly. Once you've got the assembly open, you can toggle on or off whether they're resolved. But there's no savings in loading it resolved and then kicking it into lightweight later. It's the opposite. You'll load lightweight first and then choose to bring those in if you need to work on them.
Okay.
All right, let me try this trick again. Now that I've loaded this thing resolved, I can click and drag this component from one subassembly into another. And now if I bring this part open or this assembly open, I should have that sitting on top of the little pontoon at this point at the subassembly level. So you can't click and drag something and switch it into different subassemblies if you're in SolidWorks and you've got the stuff loaded. You notice that I didn't really need to load it into RAM though. A lot of this stuff is still lightweight. It's just a large design review. I'll let you do it from that portal. Okay, let's take a step back and just go into a blank assembly and talk about what's in the assembly file. So if I go in here and I open up a millimeter assembly, when you browse for something, and I'll bring up one of these parts, you can see a preview here. That's just a 2D thumbnail. When I say open it, and I move my cursor over the green check mark, notice that it snaps into position. If you just hit a green check mark when you're inserting a component, what it'll do is it'll drop the component origin right on top of the assembly origin. So their front planes match, their top planes match, their right planes match. I'll go into that insert component again. This time I'm going to hit this thumbtack It allows me to put more than one item in. So again, I hit that green check mark. It puts it into position. These have been modeled in place, meaning that they're actually modeled in the orientation with the origin of the model where it's supposed to be in the assembly. And that's why these things are just sort of snapping into place magically. Another way you can bring it in is if you go to the File Explorer here, you can browse from this as well and go into a folder. Again, notice if I hover over these, I get those thumbnails again. When you're right-clicking and dragging, watch out here, because if I just drag and drop this anywhere, it's going to end up anywhere, wherever I put it on the screen. But if I move my cursor over the assembly origin, notice how the part snaps into place. So you're never going to get it this way. You're never going to match those origins up. Just impossible. You're going to be off by some fraction of an inch. But if you move your cursor over the assembly origin, it snaps into position automatically. And you'll see when I do this, whether I drop it onto the origin or hit the green check mark, it does the same thing. It brings it in fixed in space and it's locked to the origin. So these will be the fastest to open up and resolve because they don't have any esoteric mates. It's just this is where the part is, X, Y, Z, and moves to the next part. It doesn't have to solve anything. I'll drag and drop another part. If you don't hit the origin, it just comes in wherever you dropped it in. When you click and drag on a component in an assembly with the left mouse button pressed in, you're moving axially. You're moving along one of these X, Y, or Z's in a line. If you right-click and drag, you can rotate about the X, Y, or Z. So that's a little bit about, motion, getting these things placed in place. The left is a linear, right is a rotational. I'm going to click on one of these components and just hide it from view. Oops, I hit transparency. They're very close to each other. Pop up. That one changes transparency. This one hides it. See, it's still loaded into the assembly. It's just hidden for now. I want to talk a little bit about this idea called smart mates. If I hold my Alt key down and I click on a flat face, like on this one, and I drag over another flat face, it puts in a coincident relationship. If I hold my Alt key and I click on a cylindrical or conical face and hit another cylindrical or conical face, it automatically puts concentric in for me. So those two are really popular mates, and they're very easy to do. So that's the Alt key and drag. You can do coincident or concentric. If I do a Control key and I pick two faces, this pop-up will give me options that I can do. You saw that happen with the Alt as well. I can override the smart mate if I want to. But you see, by Control selecting them, if I give it a second and let this pop-up happen, I can put in a mate like that. So I've done 3 mates without having to get into the mate tool, get out of the mate tool, do any of that. I can do it all right on the screen, just holding hotkeys. You can Control select things. Again, that does multiple selections. Like if I want to hide these, I'm going to show the other side now. If I do want to bring in another component, show this one, you can hold your Control key and just drag and drop another one. You can either do it from the Feature Manager tree or from the screen. So if you pick the graphics on a part and Control, drag and drop, it'll put that another instance into your assembly. So I showed you the fact that if I pick a flat face, I get coincident. Cylindrical face is concentric. There's a twofer offer as well. If I hold my Alt key and I pick a circular edge, and I hit another circular edge, it puts in the concentric and the coincident in one shot. So when you snap circular edges, so this is great for putting in nuts, bolts, washers. You just grab a circular edge and just start banging them into the holes.
Does it even lock rotation?
Oh, that's a good question. I was locking rotation by putting in a parallel here. It does not lock rotation, but what you can do on any concentric mate, you can right click and they've added this lock rotation.
Okay.
So
Oh, yeah.
you need to put in a concentric and then you can lock that into position so it clocks wherever it is currently forever. Take a look. See how these things have F, F, F? Those are fixed. This one without any symbol, that one is fully defined. If you have a minus symbol in front of it, it means it's free to move. But you can see that whether I do the lock rotation, it goes away. You can also unlock the rotation. Or whether I actually go in and put a real mate once I've given it, you know, frozen all 6 degrees of freedom, so it can't move axially along any of the axes. It can't spin around any of the axes. Then that thing's fully defined. And again, that's sort of the sweet spot you're looking for as far as when the mates have to be reevaluated. If it's fully defined, the thing, it goes fast. If it has to sit there and go, oh, it's a width mate, where's this part, where's that part, those take a long time. But coincidence and concentrics are shorter than that. Fixed is the fastest because it doesn't have to do any solving. It's just there where it is.
Would you recommend locking rotation when it doesn't?
I have been locking rotation just because they put it in there. It's nice to do. It's not crucial, but especially because, you know, when we start rolling up into subassemblies, if that subassembly is flexible, it's not solving for it anyways. Yeah. So it's not like it's going to build up if I have every screw able to rotate. It's going to kill me at the top level. Mm-hmm. If you've got it in subassemblies, it won't. If you don't, it will. It's a good idea to have subassemblies because you put in a little bit of a shock absorber as far as how much calculation it has to do. If the thing's coming in rigid, not much calculation at all. Okay. We have a program here called Agile that has a lot of parts in it. So if I were to look for, let's say, a socket head cap screw that's for an M630, there's a bunch of files here already in there. I can click on here, go to attachments, and hey, what do you know? There's a step file in there. So this step file was actually generated from McMaster-Carr. When you're in McMaster-Carr, and you're looking for a nut or a bolt of some size, once you've found one, when I go into the detail of that product, I can actually download a file. You do a step file, or you can do a native SolidWorks file. I suggest a native SolidWorks file to begin with, and I'll show you why. If I open up this step file that someone has saved in here, it's taking a long time to make this, and that's what I was worried about. So this is way too much detail. It's even got an issue with the solid model. Okay, that's fine. I'll heal this up. Now, using this model won't necessarily kill you, but it may hamper your performance greatly, especially if you make something. So if the things are all drilled into their or bolted into their holes and you can't see the threads anyways, there's no loss for when you're rotating and it's drawing the graphics because you can't see these. But if you turn it to like a hidden lines visible, or you make the part that's around it transparent and you can see those threads now, when you're rotating this thing, if there's 144 parts and they've all got threads, it's got to do 144 threads every time you rotate. It's got to redraw those. And so you'll see hangups in your graphics if you've got a lot of over detail like this has. If you have opened it up from the SolidWorks file, so this is an example here. This one was done from the SolidWorks file. This is the McMaster-Carr part, but I can actually suppress the threads. If you're dealing with that part that I just had open, I can't suppress anything here. You can shield it. I can go in here and just create geometry that goes over the threads. And that's good enough for what I need this bolt to be inside of my assembly. It needs to fit inside the hole. It needs to show up in the bill of materials, but I don't need to see the threads. I mean, we're not putting our own threads into the bolts. We're buying these, so there's no reason to model that. So just a little caveat on the stuff that we may have here in our system, but also the stuff that you can get from vendors sometimes has too much detail. If you can suppress that detail, that is great. When you are in the same screen, meaning the assembly screen, and you want to do SmartMate, you need to hold the Alt key down. But if you're in separate windows, and I grab a circular edge and drag it to another circular edge, I can do a SmartMate without holding down a hotkey. And so that's typically how I'll put in a bolt. I'll just open up that bolt, bring up the assembly I need to put in, and just start putting as many bolts as I want to in the holes.
Oh my God, I needed that Monday.
There you go. That's what this class is for. Sorry I didn't have it ready for you on Monday. So here's another part. Again, it came from Agile, looking like that. So I just extruded a cylinder over the top of those threads to give my computer a break if I ever go into wireframe or anything. And so, again, you can snap with this. If it's coming the wrong way, just get your Alt key, toggles the direction that that SmartMate's going to go in. So here we go. I've got some hardware in here. There's different ways to repeat things. One way is to do a pattern. I can do a circular pattern here and say I would like one of these nuts and one of these bolts around here. Now, for what I can pick as far as the axis for the pattern, I can pick a cylindrical face, a conical face, a circular edge, or an axis, or even just a sketch line. So it's pretty open as to what you can select to give it the direction. It's set to equal spacing. So I'll just crank this up. That's probably the easiest way to do it. So this pattern, if I need to change it, I can edit this pattern. Just go in here. It's just like any other pattern. I can put more or less. Maybe if I needed to add a washer in there, I can do that. You can also right-click and dissolve a pattern if you want to, and it just puts the components there. But now I no longer have the ability to change the instances or to add another component to the pattern. The pattern's gone.
If it's in a pattern, it'll still show up on BOMs that you make?
Yes, it will still show up in the bill. Actually, let me undo this because you'll see that underneath the pattern, here's the actual components themselves. So they are taken account of, and when you get a bill, it shows the total count here. Okay, another component. Hey, that's the one. I want this in here. Of course, I'm going to make my life easier on this one. At least I thought I was going to. Yeah. I pick this circular edge, hold down my Alt key, put it in there using the Peg and Hole SmartMate, my favorite. Another way to quickly populate items, especially if they're in a regular pattern, because you see this thing isn't actually a square, something like that. I could do a rectangular pattern, but then I'd have to keep up on it to make sure that it was spaced right. Another way to make copies of a component is to right-click on it and choose to copy with mates. What this does for you is it says, okay, here's the components. You can do more than one component on this page. You go to the next one, it says, okay, I'm going to make a copy. You got a concentric and a coincident. Tell me where those were. Okay, here's the new concentric. I want to use the same coincident. So if you're checking that repeat, just it's going to assign a coincident with the same parameters as the original. When I hit the green check mark, I just keep doing that. And it just keeps putting in parts until I hit the red X to stop it. But you'll see in each one of these components, there's going to be mates. A couple of ways for you to see how a part is mated into an assembly. One way, in your feature manager tree, you can click here, there's a folder that shows you the mates just for that component. But a better way, what I typically like to do, because it's graphical, just right-click on it, and there's a choice, View with Mates. You don't even need to right-click. A left-click will do it. It's this mate icon with the eyeglasses. When you click on that, it shows you the mates that are on that part and hides everything except for the parts that it's mated to. So you can even edit a mate right from here if you wanted it to be measured as a distance from this face or something like that. We could do that instead to change what the mates are. So you can edit it, you can delete a mate from here. So a lot of things you can do inside that view mate command. But there we go. I've got an assembly here.
How do you get out of that? Sorry.
Oh, just click somewhere. So to get into it, it
Yeah.
brings up this box. When you close that box, you get out of it.
Oh, it just returns automatically.
Right. So when you hit the X here, it takes you back to the regular assembly mode. Okay, just a few more parts into this assembly. Before I go into the other parts here, though, all this stuff that I've got here, remember I was talking about if things are free to move, it takes longer to solve. All of these are free to move because I didn't lock rotation on a single one. Somebody asked me this earlier, do you want to lock rotation on all of those? An easier way is just to select everything that's got a minus in front of it and hit Fix. What that does is it suppresses all the mates that are in there and just has it, boom, at XYZ location. So now it made it easier for SolidWorks to do it rather than, oh, it's mated here and concentric and a lock. It's just there.
But if you change some part, it's going to be really bad. Like if you change the diameter of that disc, then it's going to.
Right, those parts will stay in place, and the mates want to blow up because they're suppressed, or they shouldn't. But yeah, you're right that doing a fix like that can be problematic if there is changes still going on.
Yeah, so if you float the part, the mates will still be
If I
suppressed.
go back to floating them,
Yeah.
the mates come back.
Oh, they do come back.
Yeah. So it just suppresses them. It doesn't delete them out of it. You can still get them back.
I ended up in a situation where for some reason a lot of the mates were suppressed and then couldn't figure out how to turn all of them unsuppressed quickly.
Well, if you go in here, you can see a list of all of them. What I would do is I would just go into this mate group
Yeah. Oh,
and
yeah.
find the gray ones, do a control select and pick all the gray ones and unsuppress them. But sometimes that can blow up. Depends if they have assembly configurations or why they're suppressed. It might not be such a great thing just to do.
Yeah. Now I remember I changed a part so the reference disappeared. So I think it suppressed them because the thing it was looking for was gone.
Right.
And I had to refix it anyway.
So yeah, if you do delete some geometry that a mate is on, the mate will stay behind it and just have an error, and you have to fix that error. Okay, I'm getting ready to put this part in here, so I will take advantage of these smart mates. I also need if I put them in some sort of smart order, be able to find them faster. Okay, so making copies, you hold your control key down, click and drag, you can drag a part. You have more than one part, click and drag, you can get both of them at once. So that control drag works for parts, whether it's coming from the feature manager tree or the graphics screen, it doesn't really matter. So, okay, I'm just rotating these guys into sort of the position that I would like to see them in. So I'm going to start mating them with these pegs. Again, if you get it wrong, just hit the tab key and it'll flip the direction. Okay, I think I'm getting it all right.
Did you get the first one right? Okay.
So these are gears. I would like to make them. There are a lot of different types of mates in SolidWorks. Obviously, coincident, concentric, parallel, perpendicular, those kind of things speak for themselves. There's other types of mates besides the standard mates. There's advanced mates, like a width mate and a profile center. I'll show you the profile center because it's pretty cool. But symmetric, limit mates, things like that, these take much longer to solve than your standard mates. Again, standard mates are pretty cut and dry. This thing's going to be here. Advanced mates, like when you're dealing with profile centers, symmetric, width, it's got to take a look at your model and do a lot of calculations for it to actually figure out the position of where that part is. So any of these mates take longer. These can also take longer as well, depending on the geometry. I'm going to be doing gear mates. The first thing I want to do actually is I want to kind of mesh my gears visually before I go much further. And I'll worry about that center mate a little later. So I'm going to do gear mates. Gear mates use a ratio. If you pick something that has the same diameter, it'll automatically be a 1-to-1 ratio. So you actually don't need to model teeth. You can just model the cylindrical shape and say, okay, this has 7 teeth. I can type in, whatever number I want here. If I want to say this has 10 teeth and this has 10 teeth, it doesn't matter if that's true or not. It's just doing a ratio. So every time this moves around, the other one moves around once. It is a good idea when you are putting on these gear mates to, before you accept the gear mate, take it out for a spin, because often it'll do this sort of thing, where that is wrong. I hit reverse, try it again, okay, that is right. Green check mark. So it doesn't really have an idea of which way is left or right. You kind of have to tell it. If you do pick geometry that does not have the same diameter, again, you can override this number. You can either put in a ratio or the number of teeth, whatever makes you happy. Again, give it a little bit of a jiggle to see if it's going the right direction. If it is, we're good.
Which two do you have selected there?
So at this point, I was doing this one to this one. I'm going to do it again on this other side, where I'm picking one of these spur gears and the drive gear. Every time. It's all right. That's why you have to test it every time. But here we go. Now when I spin this one, it starts going in that direction. So I've just got one more part here to finish this gear mate. There are things you can do to select a lot of items. You can do, you left click and drag. If you right click in the feature manager tree, we can hide a bunch of stuff at once if we need to. I'm looking for this because I'd like another one of these. Even if it's hidden, I can still click and drag it, get it to come in. Put my L key down, take and hold. Here we go, and now I can show one of these guys. When I hit mate, it'll take a guess. It's not always right. If I switch what it is, it'll put it back to where it was. And again, take it for a little spin here, say okay. That was weird. The take and hold kind of went away. But let's make that concentric again. Oh, it went all the way away. Weird. All right, rather than stressing on it, I'll just continue. You know that when you select somewhere here, you can do a select other. So I can put a face that's on the back face. There we go. Okay. I can group select things here. Show components. You can also group select stuff graphically. Maybe change transparency. And then I can get an idea of whether this gear train is working correctly or not. But there we go. Just the mates. Really what I wanted to show you was the smart mates and dragging from a window. Really nice tools for populating things easily. Also, kind of talking about the hierarchy of how difficult a mate is to solve. When you have to look at geometry, that's the toughest one. When you're looking at something like this where it's a ratio, it's not that tough because it's just got to do the mathematical, but it is tougher than like a coincident or concentric where it's locked into a position. All right, any questions on that example right there? All right. Okay, next thing I want to talk about is getting information from other sources. So I showed you McMaster-Carr, Agile, definitely important ones because those are from inside Google or a mainstream supplier. But there's a couple other places that people get information from. One is GrabCAD. What GrabCAD is it is a place where people upload 3D models. It's a sharing program. It's kind of like a wiki type of thing. So if you ever wanted to get a rocket engine, why, this would be the place for you to get one. You can also search for things. So I did my own transfer case because I want one propeller swings going one direction, the other one going the other direction. I also want to do a gear reduction so I can take a look at what people have for planetary gears out here. So I took a look at this one. They do put in little graphics here. This guy really did himself a disservice because he has made it look like it's a trash can when in fact it's got a full planetary gear inside of it. You can see that this is just loaded by some guy out there in the world who has internet access. So not really sure on, how accurate this is. Also, sometimes I'm not really sure on how proprietary this is. Sometimes people will load demonstration stuff or stuff they're working on for a company up there. You do not want to use that because you can get in big trouble if you're using proprietary information. But there's other stuff that, like this one, this is a two-stroke boxer engine that I'm taking a look at. I think I want to do a 4-barrel, but this one's a 2-barrel. We can click and look at that, and again, this guy did a little bit more rendering. See, put it out in the woods under a tree. Do that. So, okay, from the looks of it, this one actually looks nicer than the other one. But if I go into opening this stuff, so it's a step file. Take a look. This is looking at all of the files inside of this Limbach folder. There's only one, a step file. When a step file comes across from another system, when you open it up, you can have it set to prompt you as to what template you're going to use. If you do not have that set up, it will use the default templates. Let me show you where those are. Under the system options, there's a default template. I have this set to prompt me. If I don't, it's just going to use these. Make sure you set these correctly because they come with factory defaults. If you actually want to use a Google template, go out and browse to whatever Google template you want to use whenever you create a new assembly on the fly. Okay, but that's what it used. It grabbed the Google assembly and the Google parts for me. And we can take a look at this. Not a lot of detail in here. So it depends on what you're after. So if I'm buying this two-stroke engine from Limbach, I probably don't need to go any more in detail than this. I just need the XYZ so that people don't run into where my motor is. So that might get away with that, using something like this for that. Also, if I hit save, and we go back into that import folder, now all of a sudden that folder has a bunch of stuff in it. So you want to be careful. Wherever you put your step file and you open it up from, when you hit save, if that's 1,000 part assembly in your step file, you now have 1,000 parts wherever that was. Common mistake is for people to put that on their desktop and open it from there. And then when they close out of SolidWorks, they have 1,000 files on their desktop. So if you've ever had that happen to you, that is why. I want to talk a little bit about save and save as copy. This gets confusing for some people, so hopefully as I go through this example, you'll see what I'm doing. If I open up this part and I choose to save it, or do a save as rather, because I have a reference model, I have the model, the assembly model that this file is in, it's going to ask me this question. Okay, when I save it, do I want to save a copy or do I want to do a save as? If I save a copy, which I'll do a little later, it saves a file that has nothing to do with that assembly. It's just a separate file somewhere. But if you choose to do save as, you're actually changing the file in the assembly. So if I give this a mock GPN, hit save, it assigns it to that part file, but it also did it inside this assembly. So when you're doing save as, when you have the assembly open, you're not only changing the file name on that part, you're changing the reference inside the open assembly as it's open. So I'll go over that one more time. Open this, save as. If I choose to do it as a save as, it's going to rename it. At the part file and at the assembly file. At least it hasn't done it at the assembly file yet until I do this. Now it has saved that. So if I go to File Open at this point and I look for that assembly, when I hit the References button, these are the parts that it's opening. Those parts that I saved out because I had it open when I did the Save As. If the assembly is not open and you do a Save As, you just get another copy and the assembly will still open the original. But that trick only works if you have a reference document open. Okay, so that was that Limbach part.
When you did the save as, I didn't notice, did the old file that was named part whatever?
It's still there.
It's still there?
It's still there. Because I hit save, it saved it originally, but now I've swapped it out.
Okay.
So I've got both files in that folder now. Just one of them is the only one that's reporting to the assembly anymore. So I want to create a new folder here. Because again, remember, whenever you open up something like one of these STPs, you don't know how many parts are in here. So it's a good idea to take a look. This one might take a while. So while it's working on that, I'll go to another spot that people get stuff from called 3D Content Central. So GrabCAD is a place just for users to upload stuff. 3D Content Central is a hosted site by Dassault Systems. It's got tons of suppliers on there. So if you're like, oh, Amphenol, I use their connectors all the time. You can go into a library of Amphenol files inside of here. You're going to know pretty much that there's some engineer that works for Amphenol that made this thing, not just some kid up in the middle of the night with internet access. So these files are usually a little bit more stable. They're certainly going to be more accurate. But this is a good place to get stuff where, again, I can't vouch for the validity of the proprietary or the geometry of anything on GrabCAD. This has a little bit more, hey, this is probably really for production. Though when you take a look at this, if I were to search for Carbu, it will do partial searches, since I'm not really sure which country they're coming from. Depends where you're from, how you spell carburetor. So Carbu is good enough. Get me carburetors from all over the world that people have done. But take a look, if it's contributed by, those other ones were contributed by Amphenol. These are contributed by, Mohammed and Leonardo. So these are user, but they're not going to be proprietary issues because 3D Content Central will not post somebody's work who isn't their own. And also, they don't really do a sweep for geometry. I've had some really terrible geometry come from some of the user content on 3D Content Central, but again, you're not going to get sued for it, most likely. Okay. So that was my little segue here. I'm back into this other 3D CAD model. So this guy put a lot of work into it. If we take a look at this thing, it's got the full planetary gear inside here with all the bearings and everything. So it's a crapshoot on GrabCAD. What kind of, the one guy just slapdash, hey, this looks like a two-stroke engine. This guy actually went in and, I guess, took apart planetary gear, and it's the real deal. So I don't want all of this. What if I just want a piece of this? What I can do is I can use a tool called Pack and Go. It's okay to use Pack and Go outside of the vault. Once items are in the vault, Pack and Go can get a little dicey. But when you're still outside of the vault or you're just getting set up to put stuff into your vault, Pack and Go is a good way to move a bunch of items at once because it grabs the subassembly and all of its components. So if I go to Pack and Go here, it shows me the 4 components that I need and the top level assembly. I need to hit save on this. I was just noticing in my Pack and Go, it didn't have a list for a name on those, so I had to save it first to actually get it to believe the names. The Pack and Go, so if I just hit save right now, it'll grab this assembly and all its components and put it into whatever folder I want. And it'll bring all the references across and everything. It'll be great. But another thing that I can use Pack and Go for at this stage in the game is I can use it kind of as data entry. I can go in here and start assigning GPNs not only to the top level assembly, but to each component. Do that again, because you can also copy and paste, save yourself a little typing here. But you can see I can dictate the exact file name for each file. So by default, it's just going to give it whatever file name it had when it opened up. But if I want to assign each one of these a particular name for whatever reason, and then shoot it into the folder of everything else, I can do that. You see it didn't make a change on this one, but what it did do for me was if I go into this guy, and I put this assembly here inside of there with all the references to that same folder location. So I picked up and grabbed the guy's assembly, but it gave me all the part files I needed as well, and it gave me the ability to generate the file names exactly for each one of them as I put it in there. I can also put this into another assembly here if I want to. Find the one after. There we go. So here's the planetary gear I'm working on. I can split the screens. Don't care about the one from GrabCAD anymore. I just care about this one that I saved out. There's a couple of different ways I can do it. But how I'm going to do it in this example is I'm going to open up the top level assembly. I'm just going to drag and drop this sub-assembly into there. Looks like we've got a difference in scale. But what I wanted to get out here is I can actually, if I want to, I can break down this sub-assembly. I can right-click on a sub-assembly and say dissolve the sub-assembly. When you do that, you'll see that it brought in the parts just as their own. They don't have any mates on them because they didn't have any mates when I brought them in. But you can bring a sub-assembly into another one and just dissolve it and then just have the component parts as well. Other things you can do inside of an assembly in the feature manager tree. If I grab items, I can put them in a folder if I'd like to. Folders are nice because it gives some order to your feature manager tree, but you can also do bulk operations, like I can hide everything in the folder at once, or show, or suppress. So not only does it give you the ability to say, hey, all these parts kind of have something to do with each other, you can turn all those parts on, off, either graphically or suppress them. So it's a great place to have a folder that's called hardware. And then you can turn on and off all the hardware in mass instead of just having to go through the tree one by one, trying to figure out where all your nuts and bolts are. Okay, one other thing that I wanted to show you from that imported type of things was there was also that carburetor that we had at SolidWorks. Remember? I would say, show me the top level, open it up. So I'm building this little subassembly that's going to be the 4-piston 2-stroke engine. I want a better looking carburetor than what that guy had on a GrabCAD. But if we take a look at this, this is way too detailed. If we go into the evaluate, hit the performance evaluation, you can see that this thing's got 46 components in it. I mean, nothing near that. I don't want this thing just to look like a carburetor. We're not actually building carburetors. We're going to buy one. So I don't need all that information in there. You can strip out information from an assembly by doing a save as and saving it out as a part. When you do this, what you want to do is you want to click this all components. Often people hit this exterior faces. Why? Because it's the first one in the list. Why not? Try with that one. This one is terrible. What exterior faces does for you is every face on the outside of that is going to be its own surface body. So you can end up with like 1,000 surface bodies in the part. Also, when somebody wants to make a change, like, hey, can you drill a hole through this? No, you can't drill a hole through surfaces. You need to trim body on every one of the surfaces and then put a cylinder in the middle of them to make it look like a hole. So don't do that, please. Do this one. When you say, I want to save it with all components as a part file, do that. Probably will take a little longer. But as we're doing that, let's take a look at why this is such a good time saver. I'll go to my performance evaluation. So I showed you all these components. There's another thing here called assembly visualization. If you click on this, a little tree pops up here, and you can sort files. Like I can say, show me the heaviest file to the lightest file. And there, that's the heaviest file. That's the second heaviest. You can even color code them. If you use this thing right here, anything that's red for this is heavy, and as it gets into closer to purple, it's getting lighter. You can change where that happens with these little drag bars. So anything that's over 10 is red. You can also sort by all kinds of stuff. I can sort by surface, by area, or I can even do it by SolidWorks rebuild time. So this shows me how long it takes 3 seconds to build that part, takes 1 second to build that part. These are all adding up, right? So when you open up a full assembly, especially if you open it up full weight, it's got to bring in all those parts, rebuild them, and take a look at where they go. It's got all that information in there. On the other hand, I've got this component that I believe I saved to the desktop. Okay, it's one single file. Actually, it's 3 separate bodies in one single file, but it's just one file that SolidWorks needs to load up instead of, the dozens that I was looking at before. Also, when I go to evaluate, I can go to the rebuild time. This whole thing takes less than a second to build, where the other thing, it would still be working on the core and on the cover while this thing's already done. So when you are working with stuff that is purchased or really complex multi-body type of thing, don't put it in as a subassembly. Do a save as part. When it opens up as a part, you'll have better performance. You can still have those things, both of them in like an EPDM system, an agile system. One's a SLD PRT, one's an SLD ASM. The only thing you need to know is this does not rebuild. So this is a snapshot of what it looked like when it hit save as. If I go into the assembly and start taking parts out, I open this thing up, it's still going to look like this. So it is a static snapshot. It's not going to rebuild. So if you do make changes and you are dealing with, you have an assembly of a part and also using it as a part at some levels, you always need to remember to refresh that part if the assembly ever gets rolled as a rep.
So this is the one where you did the save as and then under geometry to save all parts, all components.
So yeah, see, it's got 62 bodies here.
Yeah.
So every one of those was a part originally. It just saved every part as a body inside of this one single file.
And the other option was like all exterior surfaces, and then you just get a list of surfaces.
Right. It would be this face, it would be this face, it would be this face. And you just have, your feature manager should just be a list of faces. And again, it's fine if that's the only thing you ever do to it. The thing that I've seen people get into trouble with is, oh, I want to make a change. I want to change this connector. I want to put a different screw in here. Yeah, we can't do any of that with what we've got here. Especially if they threw out the original assembly, which also often happens. They'll just save the part and be like, oh, we don't need that assembly. We got the part. Well, that part is a snapshot in time. I can't really make changes to it.
So I do this a lot for PCBs.
Yes.
When you get some export data from Altium or something.
Right, and I'm going to show a PCB in this.
Okay.
And go through the steps on that, but it's similar. You want to do a save as part on that.
Yeah. Okay.
This ends up in the bottom as one item as well. So
right, and so you don't have the indented, all these screws that takes to put in a carburetor because we're not building carburetors. So it's good that those things have gone away anyway. All right, let's go to open. Let's go back to that top level. I closed it out when we walked across the way, but could have had this open in the background all the time because this is really, when you've got this large design review, it's just a glorified e-drawing. It's an e-drawing that I can, investigate stuff and open files from quickly right inside of SolidWorks. But that wasn't even the one that I was looking for. I'm looking for this one. Okay. So here's that Limbach two-stroke engine, but I decided not to use that guy's very simple one. I've got a pretty simple one, but it's got more detail in it. And I want to use this one to build it with. Here's our friend, the carburetor part that we saved out. But I want to have another one of those over here. You can create sub-assemblies on the fly. Inside of this assembly, I can group select all the items I want, right-click and choose to form a new sub-assembly. Before I do that, I want to talk about a particular option. The option I want to talk about is, in assemblies, save new components to external files. That is not checked on. What that means is that anything I build in context, like a subassembly or a new component, is going to be what's called a virtual part, which means it's embedded into the assembly. If I turn that off, what it'll do is it'll actually save an external file. And I'll show you that from both directions here in a second. But I want to right-click and say, let's form a new subassembly. I have to give it a name. So we assign its name, and there we go. It's given me a file with all those files inside of it. So I can turn these off, because they're subassembly, turn them back on however I want. I can also make a copy of it. I showed you the control drag. You could do it from the screen or from the feature manager tree at the part level. At the subassembly level, you can't do it from the screen, because when you do it from the screen, it gives you a copy of the component that you were actually dragging on. So at the subassembly level, you can hold your control key, but you've got to bring it in from the feature manager tree. Once you got that, it's not too difficult to put this together. You can use smart mates at the assembly level or at the subassembly level. Get that thing into the position that you need. Okay. Earlier I showed you what a save as copy does. I'm sorry, what a save as does when you've got the assembly open. This time I'm going to do a save as, and I'm going to choose to do a save as copy. Both of these do a save as copy. It's just whether or not you end up with a window open or not. If you say save as copy and continue, it saves the part independently, has nothing to do with the assembly, into its own file, but it does not open in SolidWorks. This one does the same thing, but it will open in SolidWorks. So here I'm looking at that new file. I've actually got both of them open. But because I chose that save as copy option, the, not that top level, this one still has the original in it, which is what I was after, because I just wanted to take that part, but I didn't actually want to make changes into that assembly. I wanted to change this part. Okay, so I've saved it out as its own independent part, so I'm not affecting the original or the original assembly, which is fine. What I'm going to do here for this part is I just want to make a 4-cylinder out of this. So I'll do a linear pattern. And instead of copying a body, I'll do a whole body. Instead of copying a feature, I'll copy the whole body. 4 cylinders, just that easy. All I need to do is pick multi-bodies. When you pick them in the feature manager tree, here and here, a right click will give you a choice to combine, and you can do a Boolean addition to get that one working. So that's a good way. If you've got the assembly open, remember to do save as copy so that you don't mess with the assembly that you have open. And that's what I did here. So this one is independent. It's not in any assembly. I'm going to put it in one now, though. So let me go to File, just pull down next to New. So let's make an assembly from that part. Hit the ground running here. I don't know if you know this shortcut, but if you hit the R key, it will open up any files that you've had recently opened. R key does that for you. All right, let's take a look at this. Unfortunately, that trick that I showed you where you can grab an edge and control, drag, and drop does not work at the assembly level. So you need to drag and drop the assembly in there first, and then you just need to do the hotkey, the Alt key. It'll still work. It just won't work that window-to-window choice.
So close.
Though there is a way. I was going to cover this earlier, but I forgot to, so let me cover it now. If I go back into this assembly, first thing, I don't want it all just floating around, so I'll fix all of it. But I can put in mate references, and you can put these in at the component level, or you can put them in at the assembly level. If you know this thing's going to assemble a certain way, you can put that in. Now, picking an edge is basically like me picking an edge and holding the Alt key. It's going to want to do a concentric and coincident on that edge. Any circular edge I hit will put this in place. So you can put any amount of edges in there. You can put, if you just want it to be planar, you can do just a planar face or, you know, different combinations. But I choose to do a circular edge so that I can just snap it, bang. So now I don't have to pick the geometry because the geometry is inside there, right? All I need to do is pick the locating edge on the other screen, and it snaps right into position. Also, if you drag it from a file explorer and it has one of those mate references, it'll snap into place from the file explorer. You don't even need to open the file. But you do need to put that mate reference actually into the file itself. And again, it works at assembly or component levels.
Can you only have, so that works similar to,
That's how the toolbox works.
yeah. That sounds familiar. So can you only have one feature or one selection for the mate reference?
No, you can have multiple. You can actually have multiple mate references. It gets a little convoluted. If you do just a simple one, like a face or a cylinder or an edge, it's just going to do those smart mates I was showing you.
Mm-hmm.
If you pick a combination, like a 3 faces, you have to have matching 3 faces on the other side. You can actually name each mate reference, and you can have a similar mate reference on another component if they find each other. Like a USB is a really good one to do that for. Where if the USB plug has the 3 mates it needs, and the USB receptor has the 3 mates, they'll just snap right into each other. When they say, oh, you got a USB mate, I've got a USB mate, let's put them together.
So it's a little bit harder to keep track of like what, if it's trying to look for the matching geometry or if it's trying to match the name somehow. Okay.
If you typically what I'll do, if it's the simple one, I won't rename it. If it's something that I'm going to have a similar mating structure on another part, that's when you actually give it a name. So if we go back into this assembly and I go into that mate reference, see it's just called default, but in here I can give it a name. Mm-hmm. If you give it a specific name, that's the first thing it's going to do is going to look for a matching specific name. If you just leave it as default, it just figures it's a stupid smart mate.
Okay. Yeah.
I can be stupid and smart at the same time.
Yeah.
Just a rudimentary smart mate, I should say, rather than, because you can get really complex with them if you name them. It's got to have a matching face on the other end for it to work.
Right. So you can, so if you name it, you can separate, like if you have circular edges that are different sizes, you can more or less filter them with the name.
Mm-hmm.
Yeah.
And wow, we can take that into another thing because you can go a step beyond that. There's something called smart component where like if you have a washer, that's again how the toolbox works. It'll resize to the next diameter up depending on the geometry you're dropping it into.
Oh.
So it gets really deeper than this.
Okay. Yeah. Step that. You get 90% of the benefit from just doing one of them.
Right. Okay. So I showed you some tricks putting mates in. Definitely that Alt key is your friend. Use that. Going window to window is a really nice trick. There's another one. If I go into the mate tool, I'll pick the front mate. I want all 4 of these cylinders to be parallel to this front plane. If you know that you're going to be mating a bunch of things at once, you can press this multiple mate mode button. It looks like a little lightning bolt next to your mate. You can also turn on this create multi-mate folder. Now I just go into my feature manager tree and I can hit what I want it to mate with. You can see that you can switch direction on any one singular reference. If it comes in backwards, right when you put it in, it'll show you this pop-up where you can accept it, reverse it, or not, or not put it in there. Once you hit the green check mark, you're done. Oh, I was done too early. These 3 are okay, but this one still not in there. Luckily, I chose to do it as a multiple mate group. If I hadn't chosen that multiple mate checkbox for the multi-mate group, it would have just dropped all 4 of them loose in as their own relations. And if I wanted to change them, I'd have to go in independently. But if I go in here and edit the feature, because I chose to create a multi-mate feature, I can go in here and add more items to that multi-mate. So not only does the multi-mate allow you to do a bunch of mates quickly, but if you leave it in there as a group, you can go back in, you can change references, you can add more components to it. So it's a really nice feature if you've got a lot of things that are lining up, like on a table, or they need to be all facing the same direction. This mate will really help you out, the multiple mate groups. Any questions on me putting together this thing?
Oh, I had a question on saving assemblies as separate parts or internal, or sub-assemblies internal to the assembly.
Okay.
Uh, is there a best practice? Is there a good reason why internal sub-assembly would be a good idea to do? Or a reason not to do?
I can think of reasons not to do it. Let me open up.
I imagine if it's important enough to need a part number and its own drawing, you should just do it as a separate file.
Right. And do it as one of those. This is what I'm after. Save it as a single part file, but to have it as an external file. Because I guess I'm not really clear on what you're after, because you can do something called a virtual component where the component only exists in the assembly. There's no actual external file for it. And that's what it sounds like what you're asking me, but I don't know if that's what you're asking.
I don't think so. I think when you selected multiple components and right click form new subassembly.
Yes.
You showed us the option of like
whether it's going to be internal or external.
Okay. Yeah, that's right.
The thing is if you choose not to do it externally, it'll save as what's called a virtual part, but that has no external file. The plus on that is that like in your EPDM system, it's not going to be looking for that extra file. The minus on it is that if that assembly ever gets corrupted or saved wrong or whatever and disappears, that part disappears with it too. That subassembly would disappear. The components themselves would still be okay because they actually were files, but the subassembly only exists in that assembly. So if that assembly ever has a problem with it, that part goes away too. So pluses and minuses, doing it either way.
Okay.
All right, let me show you. So I was talking about some mates. I didn't want to do, I could do a whole hour on just the different mate types, but I want to spare you all that and just show you some really cool ones. One that they added recently, so they've had a width mate, which is you pick two sides of the part, you pick two sides of another part, it centers them up, and you do it for the other sides. They've done this profile center where if I pick those two faces, it just centers them up. So if you've got a rectangular face that you're mating a rectangular item to, it'll just center it in that rectangle. If you're doing a circular to circular, it'll just center them right in top of each other. It is just like a width mate where now it's got to calculate geometry every time it solves that mate, but it's really nice for putting stuff smack down in the middle of something. Just like that. It would have taken me 3 mates at least, and this got the job done in 1.
Probably a good idea to do that and then just fix it.
Yeah, that's also another way to do it. If you are worried about mate speed, again, depending on how your structure is, if you have nothing but a flat structure for your entire assembly, yes, do that. But if you've got sub-assemblies, you start hiding that stuff because sub-assembly is rigid. It's not solving for that anyways.
Sure.
Does it work for irregular shapes?
As long as the other profile is the same irregular shape. Well, you know, like a hexagon.
Non-planar.
No, not non-planar, because it's got one of the ingredients is a coincidence with the two profile faces. But as long as the geometry, like the XY geometry, is the same on both faces, it should center it. Okay, that's one thing. Also, how about this? We've got a space heater in this thing that's got way too much information. We're not building space heaters here. So that's another one of those things where you'd want to save this out as a component. You need to switch the file of type to part. And say you want to do all components. And that saved that component out into space, but it didn't do anything for me here. I've still got this same subassembly. For this type of situation, what you need to do is first you want to find the original. That one is a pattern. is if I right-click, I can, actually I need to right-click and then click the double arrows at the bottom to find what I'm after. I can replace one component with another. You can swap out a assembly for a part. It doesn't care. It's not going to say, hey, that was a part. You can't do that. What it is going to do is it is going to show you, hey, this thing mates up to another part. So all you need to do is give it the corresponding face on that new part you got, and it puts the mate back. Now all of a sudden I've swapped out the space here and its pattern with just that SLD PRT. But just by hitting Save As, it's created a part file for me, but it didn't do anything to my subassembly. I have to go in there and say, okay, swap this out. But that's how you can do it. You can right-click a part or an assembly and switch them out with either a part or an assembly. You can mix and match.
When it asks you to select the new faces to replace the mates, I always get confused on...
You're selecting them on the part that you put in. Also, it allows, if I hadn't just hit it so fast, it allows you to move the part out of the way. Because a lot of times the thing is sitting where it's supposed to be, and you're like, well, the faces I need to pick.
So the small window that pops up is the old part?
That's the face on the old part.
Okay.
And then you need to pick the corresponding face on the new part in your graphics screen. If those two match up, like it's a cylinder and a cylinder, or flat face and flat face, it's okay. If you pick a face that has nothing to do with it, it's going to give you an error. But if it's a corresponding same type of geometry, it'll put it in there. You can also swap out stuff when you're doing an open. If you pick an assembly and you hit references, if I double click here, I can swap the reference before I even open the assembly. The trouble is when the assembly opens up, all the mates just go kablamo. So instead of stopping and say, hey, you broke a mate, could you fix this one? Could you fix this one? Like it does when you do it live. If you do it this way, all the mates just blow up and you have to go and fix them manually. So that's why I typically like to do it from an open assembly so that I know that rather than me pulling the rug out from underneath a mate, I can go through there and say, okay, this face goes here, this face goes there, and have a lot more confidence in the thing being put together correctly. Okay, and as promised, I'm going to do a PCB board. So again, these things can get pretty big. So this one is
nice,
pretty big. It's got a lot of information in it. That's why I put it in its own folder, because that folder is going to go from having one file in it to having hundreds, just by the fact of me opening up this assembly and solving it. So this came from Altium. We have some discrepancies between the MCAD components and the ECAD components that we use here at Google X. So the guys that are using Altium, they have their own library. The X and Y, the footprint of them are pretty much the same between both systems. It comes into the amount of detail in the Z heights. Get a little iffy as to who's got what when you look at it. But typically what we want to do from our mechanical side is get a fresh copy from the guy in ECAD, say, send me the whole thing, and this is what you would get. Again, we can take a look at this performance evaluation and realize that I don't want to have 300 parts in my assembly. I just want one part in my assembly. So that's when we do that file, save as, and switch it to a part file. Again, make sure you hit this all component. One of the biggest things that, especially with these PCB boards, that gets to me is somebody wants to make a change to one and it's all surfaces, and I can't really help them with it. Where if it's solid bodies, you can hide and show solid bodies. You can drill a hole. You can cut them off. You can do all kinds of stuff with a solid body that you can't with surfaces. Okay, so I saved it out as a part and then closed out of this thing. So now it's only 10 meg. So I got the size down a little bit by creating just a single part file. And you see it still has all these bodies inside of it. I did read an article where they were talking about the fact of doing a combine for all these. You might save more and more information as you kind of glue it together. I don't really know how much value that adds. Once you've got it down to one part, I think that's pretty much. It's still going to have a lot of detail in it, just graphically. They really went to town on that PCB board. You know, it's got every pin and everything in there. But now I can make that in here. So is this sort of helping with the question you had on what's the best practice for a PCB board? Because that's typically what I would do with that type
Yeah,
of
that makes it small and fast enough. It's
right. So it loads up as one part. It comes up as one part in your bill of materials, as rather than, you know, if somebody just drops that subassembly in there, now it takes forever for this thing to load up. I've got this huge, you know, RAM monster every time I open this assembly. How come my computer keeps running slow? Oh, because half of your RAM is filled up with transistors and resistors and all this other crap that you don't need. All you need is one part.
yeah. I had been using the save as workaround, but I think I had the exterior surfaces.
Right, and
checked.
that's the one that's on by default. And so we get a lot of them. And just hopefully more people are watching this and getting the word out. Stop doing that. Save as solids. It makes your life easier. It makes people who work on its life easier because it opens up faster and you can make changes.
Mm-hmm.
Okay, one more example here. Got this trailer that I want to open up. So I talked about mates and file geometry, things like that. You can also do patterns. I can do linear component patterns. You saw me do a circular one, pretty much the same as their counterparts at the feature level, where I just pick the component that I'm after and give it the spacing that I want. Almost there. There we go. Good enough for government work. Put that in there. So for those, I also want to do a pattern, a mirror pattern. So you pick the plane that you want to mirror about, and then the components that you would like to mirror. These components are pretty simple, but we've got some other components here. It might be a little less simple. When you hit this next arrow, it'll show you a preview of what that mirror looks like. So these simple rollers, those went fine. This other one, it kind of went haywire. So it puts me into this where it shows me the position they're in. I can actually toggle the position on this thing about the X, about the Y, about the X and Y. So there's 4 different positions. Sometimes it'll look like it'll work. Sometimes it will look like it won't work. If it works, then all you've had to do is it guessed wrong on the orientation on the other side. If you can't get the thing to fit for the life of you, chances are you need to have a left-handed version of that. So if we go back one level and we click on this component here, there it is. So this is the component I'm having trouble with. If I click on that component there, I can hit this bell. Anything with a bell here is going to automatically generate another component that is mirrored. When you do have a mirrored component, it'll ask you whether you're going to put a prefix or a suffix on it, or you can even put in a custom number if you want. So this will give me, I got the component pattern, I have the mirror, I've got a mirrored component going on. It keeps giving me that question about the large design review because I've still got this thing open where it's asking me if I want to regenerate the graphics. See how the graphics have not been regenerated yet? That's because I just told it to hold on for a second. Okay, so here's my mirrored components. Again, I can dissolve these if I want. You can notice that this one's been assigned that new part number that I gave it. And it's just the mirror version of the other 300 If I open this part on its own, there it is. It's got one of these things. If you ever see that minus symbol with a greater than symbol, either at the very top of the tree, here, or on a feature itself, that means that you have an external reference, which we don't like here. External references can get a little dicey, especially when you've got stuff inside of data management and things have been released, because external references basically means that it's going to open up another part to generate its geometry. How this thing gets built is it opens up the 300 version and then mirrors it. So if the first one's been released and this one hasn't, or something like that, you can get into problems over, oh, now we're about to make a change to a part that has been released. We don't want that. So if you don't want an external reference, you can right-click, list external references. There's a choice to lock or break. Lock is nice because you can take it back later. So if I choose to lock the references, what it'll do is it will flag the reference with a little asterisk that lets me know there is a reference, but I'm not going to update it. So if the original changes size, this one still stays the size that it is until I right-click, list external references, and unlock it. So that's the power of the lock-unlock is I can choose, oh, I changed my mind. I want it to rebuild again. And so you can do that with that lock and unlock. However, the one that we want you to use is break, and it'll give you a warning. You cannot activate these again. There is no unbreak. When you do a break like this, the external reference goes away, and it'll always go away. If you want the external reference back, you have to regenerate the part from scratch. You can tell if an external reference is there or not, because when you do a pack and go, if it shows another item here, if it had shown the 7x300, that means that, oh, it's still got an external reference to it. But if it just shows a single line in that part, that means that it's independent. You can dissolve mirrors and patterns. If I dissolve this mirror, it means that I can no longer edit it. I can't add components to it or change where the mirror is, but it does keep me this part. It saved a hard copy of this mirror image for me, so I don't have to worry about that going away when I dissolve it. Okay, sure, I'll save all. And yes, I'll save the graphics. And again, the only reason that graphics question is coming up is because I have a large design review open. And now you'll see, since I said yes this time, it republished the graphics in here for me. So that answers your question from way back as to whether that stuff gets updated. If you say yes, it does. If you say no, it doesn't. Also, inside of the assemblies, if you check this on, it won't ask you. It'll just do it every time you save the file. It'll resave the graphics information.
And if you didn't have it open, if you open it now, it would be updated.
Yes. Okay, last example file I'm going to open up here. Sorry I'm a little late, but we had kind of a weird break in the middle there. Taking a look at this part. So obviously this is not large design review or large assembly mode because I can see everything going on here. Maybe I want to hide some of this stuff so I can work a little easier in here. You either hide it globally here, or you can select on something like a sketch, hide it there. Now when you do that, when you hide a sketch like I just did, it actually hides the sketch in the part file. So if I open the part file, it'll be hidden there too, where this is just at the top level of the assembly. It's not affecting the parts underneath it. Okay, I want to put in another part here just to see where I'm at. I want to open up this part. And I want to put it in this assembly. Now the reason it's already in that top level assembly is it's considered part of the airframe. So the pontoon and that piece are both at the airframe level. This assembly that I've got here is actually like the stuff that goes in the pontoons. But I want to see where the extents of the world are. So I am going to make this thing into position here. There we go. But the thing is I don't want this thing double counted. And it's not really, when I'm asking for the weight of the stuff that goes in the pontoon, I don't want that counted because that's already counted in the airframe. So to not double count this stuff, what I'm going to do is if I click on this component and go into the properties, there's a choice to create this as an envelope. You'll see it gets this little envelope icon in front of the part. You can also, when you go to insert a component, there's a choice to make it an envelope right away when you bring it in. So what is an envelope? Well, one thing it does, you can notice it's turned transparent, so I can see through it. That's kind of nice. But what's really important is the fact when I go to the properties, this thing is excluded from the bill of materials in the SolidWorks bill. So it's like a found part. Also, it's excluded when I go and do the evaluate, go into mass properties, it'll give me the weight, but this is the weight without the envelopes. So they're not counted in the bill of materials, they're not counted in the material at this level in SolidWorks. Let's talk about in-context design. There's a couple of ways to do in-context design. I guess there's a few ways. One, I showed you a long time ago when I was playing with those valve covers in the radial engine. I can actually make it taller and smaller in the assembly. That's in-context design. I'm just changing a dimension at the assembly level. But a more intrusive type of in-context design comes with this edit component choice. If I select on a part and choose edit component, I'm working in this part, you'll see the one that turned blue, at the assembly level. Now what that does for me is it allows me to start a sketch on this base first. Sketch here. Hide the body. It allows me to grab information from inside this assembly. So I want to make sure that these holes that mount up my jet drive are cut into the back of that boat shape. And I can do that either with an offset or a convert, copy it into that sketch. I'm going to do another sketch here. And I want to pick all of the tops of these motor mounts. You have the option whether or not you want everything to go transparent or not. By default, this is what it looks like when you are in context editing. Everything except for the part that you're working on, this big green part, goes transparent. I can change that if I want to maintain transparency or force transparency. I can switch those around on the fly with this setting. Now, it does get tough for me to pick things when you are looking at this like wireframe of the rest of the world. That's where those filters come in. If I press the letter E, that'll filter edges. And that gives me the ability to go through all of these faces really quickly as far as grabbing the edges from these motor mounts and then converting them down onto the sketch that I was working on before. Okay, so I can do the rest of the work. I don't have to be in the assembly. I could be in the assembly. Either way, I can use these sketches to cut the holes that I need to in the part. So I know those are going to fit the jet drive. I know these things are going to fit those electric motors. They want me to go left, right, and reverse. Okay, but I've got these things, these blasted external references. I showed you a quick and dirty way. Just right click, break them. You're done. It's not going to look at them again. A much cleaner way of doing it so you actually don't have any trace of it, because remember when you break it, you just get a big X next to your external reference. But if I go into this sketch, go to display delete relations, set it to external, and kill them all, there went all my external relations. Okay, but this could be dangerous now, because now it doesn't necessarily have to be where I got that information from. So the next trick I'm going to do, if you have an underdefined sketch, click here, go fully defined sketch, and it'll throw whatever dimensions it takes as far as diameters and X's and Y's as to where those holes are, and now it's fully defined. It no longer has the magic ability of when the mount changes, the assembly is going to update. That's what an external reference does for you. It gives you like that real-time change. This allows you to take an external reference and get rid of it. You see, now this sketch has no recollection of ever having an external reference. So it's pretty easy. You just kill them and then put them back, and it'll just measure off of the model that you've got. And now I have no external references. Hooray! So like I said, there's 3 styles of in context. You can just change a dimension inside of a part that's already existing. You can grab geometry from it as long as you remember to go and get rid of it. You can also build a part right in the assembly. So this is called top-down modeling. If I go to insert a component and choose to do a new part, ask me to give it a name. I'm going to ask you to stop asking me that next time, I swear. Okay. Now, I've said, okay, I want to build a part in this assembly. And all it's doing right now is it's giving me a green check mark next to my cursor. Anything I touch right now that is a plane or planar face will become the front plane of my new part. So if I pick a face off the back of this boat, that's going to be the front plane of the new part. My suggestion, what I like to do, is always just hit the front plane of the assembly. What that does for you is that locks the origin of the assembly and the origin of the part in the same place. So you're modeling sort of in the XY location that you want to, instead of somewhere, relative to some face that you picked. So by picking that face, it automatically dropped that new part in. Here's the part that I named. It puts me in a sketch on that plane, and it thinks I want to start sketching. I actually do not want to start sketching. So I got out of the sketch. I'm going to hide this component. What I want to do is I want to route an exhaust pipe from the motor here up through these holes inside of my pontoon. Instead of me grabbing information and then going into the part later and stripping that out manually, there's this magic button right here called No External References. If you turn that on, you can still get geometrical information from an assembly. It just automatically breaks the link for you. So it does like a right-click list external break for you on the fly. I'll show you what that looks like here. So I want to copy these 4 faces to know where the exhaust is supposed to be coming out of the boat. When I go to surfaces, offset, it gives me a warning. Hey, you asked me to break all the relations, so I am going to. If you say don't show again, it won't show it again. But that's what it's done. If I take a look at this component, there's a external relation on there, but it's automatically been broken for me. So that's typically how I like to operate when I'm doing this kind of stuff. Oh my gosh, I can't see anything. Okay. worked for me before, but hey, I'm able to pick out of this rat's nest. It's probably my first time with this file set. So I'm going to grab these two faces, do an offset. Actually, it's only going to let me do one at a time because they're actually coming from different models. I was able to do all 4 holes earlier because they were all coming from the boat itself, but because these are coming from separate cylinder heads, I have to do them separately. But now if we take a look at this component, if I open it up on its own, there they are. Here's where my exhaust pipes need to go through. I'm going to start a 3D sketch here. And these are going to be really simple, so don't judge me. That would take longer if I was actually designing this, but I'm going to do it really simple where it's just going to be a pipe that has a bend in it. Okay, so I'll draw one there. That sketch. The second one will take a little less time. I just want to find the center of this and then work straight down. Connect the dots and make this thing parallel to my top plane. And round off the corners. Okay, so that's where I want my exhaust pipes to go. They do have a new thing in SolidWorks 2016. When you're doing features and you do a sweep, if you set this to a circular profile, you only need to pick the path. Yeah, I should pick the path first. Oh, I see the problem. Whoops. I thought I started a new 3D sketch, but I did not. I can go really fast. Okay, so sorry about that. I want to do them as 2 separate 3D sketches because you pick the sketch, you go to surface, you go to features, sweep. If you choose a circular profile, it just sweeps a circle down that path. You can even tell it to do it a thin feature as you do it, so it can actually create a pipe for you. But this is the type of thing that you do for routing pipes, routing cables, that sort of thing, is you can grab the information from the assembly. If you have that break references on it, you're just stealing the information temporarily. The assembly could change, but typically if you've got an assembly changing that much, you're going to need to reroute all this stuff anyways. There we go, a couple of exhaust pipes. If I show the component, you can see that those match up with the holes. Now, if the holes move, they're not going to move with it because I broke those external relations. If they still had external relations, they would move. So you can do that type of stuff. There was another example that I did in a large design. It's nice because when you click on this, you can see it highlight which one is which. So I was after this one. because there is another way to grab information without having external references. And I did it in the example of these distributor wires, where they kind of crazy go everywhere. How I created this was I actually, inside of the assembly, opened a 3D sketch. And this is what that 3D sketch looks like. So it's just copied where the tops of the distributor caps are and where the tops of the spark plugs are. And then I was able to just run splines in between those. But I did a 3D sketch, convert entities, copy the 3D sketch and paste it into another part. No external references, yet I have the information on where every one of those is in space at the assembly. So some other tricks on if you need to build something that's form-fitting, not getting those external relations, there's different ways to do it. You can either turn them off or you can just copy and paste a sketch. You can even copy and paste 2D geometry, like these holes where the thing mounts up. If I want to have that in the boat, I can copy this sketch from the cover, go back to the base. Don't mind this one. Paste it in there, and there it is. I've got that hole pattern already in there. You want to be careful with this because just like when I erased those relations and was able to pull the circle around for the mounting holes on the jet drive, same thing here. Those aren't locked down to anywhere. They just come in the same location that they were copied from. But because they don't have the geometry that they were locked to, they're no longer locked to anything. I can fix that if I just box around it and make it into a block. Now you'll see it'll move as a unit and it'll keep the integrity of that shape and size. I can even put in construction geometry, if I need to help me center this thing up. So from the drawing, I can pick the mid-plane, have it go collinear. Now I've got it in the correct orientation. I just need to put it where it goes on the boat. Now I can drill the holes for that sketch. Oops. Yeah. So I snapped to something that I didn't mean to. There we go. So you got to watch when you are dragging this, see if I snap to that, that point's going to be on the edge. So you want to make sure that you've got it in the correct location. But then I can use this as a template for a hole widget to go punch holes in there. And I know it's going to fit the part it's fitting to because that's where I got those locations from anyhow. So different ways of transferring information, either manually like I'm showing you here, copying and pasting 2D and 3D sketch geometry, or doing it in the model. Just remember to turn off that or turn on that break relations automatically, and then you don't have to worry about them accidentally cropping up. Okay, so that was assembly design. There's a lot more to assemblies that I probably will talk about at a later date, but this is a good one because these are questions that people ask me all the time as far as external references and making things up quickly. You have any final questions for me?
Breadcrumbs.
Breadcrumbs. Holy cow, I didn't talk about breadcrumbs. I was supposed to do that. Okay, what are breadcrumbs? They're relatively new. If I pick on a part, apparently large design mode does not do this, so let's turn off the large assembly mode. And set lightweight to resolve. Hey, Monty, you just made the ending. Cool. All right, so if I pick on something, apparently it all needs to be loaded. You know, I couldn't do it in lightweight. But once I'm not in lightweight, if I pick on something and hit the D key, you'll see that it shows me the body that I selected, the part I selected, the subassembly. So I can open this subassembly right from here. So without going into my feature manager tree, I can drill down into subassemblies or components very easily. And again, what that is, you hit the D key and it'll show you all the levels of whatever you just selected on. You can go to that level, either open it up or edit it or do any sort of operation with that particular component once you've selected this. Do you want to edit that? Do you want to open it? Do you want to hide or show it? And it's rather than just the component that I selected on, it's editing that subassembly that I selected. Thank you for reminding me about breadcrumbs. I almost got out of here without talking about them. I'm still trying to, since it's a new thing, I'm still trying to use them myself. When I remember to use them, I'm happy about using them because I don't have to go searching for stuff in the tree. It's just one of those things of getting muscle memory to this is something I do, hit that D key. Because they do show up whether you want them to not in the upper left. I'm terrible at that because then I have to, it's just as bad as going to the tree. But once they talked about the D key, it always pops up wherever your cursor is.
Is that a 2016 feature?
That is a 2016 feature, yes.